So we're going to talk about writing equations from data today. So I'm going to give you guys 2 points, and then we're going to turn that into an exponential function. Now, we've done that before. We've done it with linear functions. So you could take these same 2 points and turn it into a linear function. You could take them and turn it into an exponential function. And we'll see how far we get with all of this stuff today. So I printed this for you, right?
Yes.
All right, so let's read it. It says a local population of insects is increasing exponentially. So, I mean, we know this is an exponential problem because population growth usually is. If there's 100 insects after 7 days and 1,000 after 14 days, write an exponential function to model this scenario where y represents the population and t represents the days. Okay, so graphing this isn't terribly necessary. I'll do it just for the heck of it. But it said that the x-axis represents the days. So we go from 0 up to 14 days, right? And then we go from, on the y-axis represents the population of the flies. It goes from 100 up to 1,000. Now 1,000 would be about 10 times higher, right? So way up there. So at 7 days it's there, at 14 days it's here. Now we don't really have enough information to know what's going on back here, but we do know that the general shape of these things, of an exponential function, gets flat against the axis and then comes up like that, right? So we would expect it to be looking something like that. Okay, now later in the block, you guys agree, can't I also connect those dots with a straight line instead, right? And so later in the block, we're going to do both, and then we're going to decide which one actually models the scenario better. When you're doing mathematics in the real world, you know, your idea is to try to find a mathematical model. You know, it could be exponential, linear, could be square root, could be any kind of function really that best fits the data that you have, and you go with the one that's best. So we're not doing linear right now, so I'll erase that. But that's what we're looking for there. Now, a good way to start here is to, once again, this part is not necessary either, but it's a nice way to organize your data just so things make a little bit more sense. We have some x values and some y values. We know that when x is 7, y is 100, right? 7 days, 100 insects, and then 14 days is 1,000. Now, this is where things kind of do get necessary. We know we want it to be an exponential function, and this is what exponential functions look like. Now, the ones we did last time had a plus c, right? We won't have that today. There's not going to be a plus c. There's not going to be some vertical rise. It's just going to be like this. And now what we're going to do is we're going to plug in the information that we're given, okay? So I'm going to plug in 1,000 for y, and I'm going to plug in 14 for the x. Okay, I'm going to repeat that with the other data points, 7 and 100. So now I'm going to plug in 100 for y and 7 for x. Now you'll notice that what I did was I put the bigger exponent on top. You don't have to. It sometimes makes the algebra part a little bit easier. Okay, so we have a system of equations here, right? On Friday, I gave you guys part of your review was to solve a system. You guys remember systems where you have 2 variables with 2 equations. You've got to solve both simultaneously. And you guys are familiar with elimination and substitution, right? We're going to do those same things here, but it's going to look a little bit differently. Since exponential functions, unlike linear functions, exponential functions grow by multiplication or division, whereas linears grow by addition and subtraction. So actually, in this case, we're going to divide both sides by each other. So I'm going to divide 1,000 by 100, and I'm going to divide a times b to the 14th by a times b to the 7th. Okay, so 1,000 divided by 100 is 10. here's a cool thing. The A's go away. And so we just did elimination in a new and weird way, but that was elimination. I got rid of a variable. And then this can be simplified too. This becomes b to the 14 minus 7, right? You subtract your exponents. So now I've got 10 is equal to b to the 7th power. So what I'm trying to do here is I'm trying to figure out what are the a and the b. What is my growth factor? And what is the starting amount so that I can plug them into this original formula here and have a function that represents the data. That's what I'm trying to do. So by doing this little strategy here, I've gotten closer to finding the b. Now, the next thing we got to do is get this b by itself. Okay? So how do you get the b by itself? What you do is you're going to raise both sides of this equation to the reciprocal power. So what's the reciprocal? 7? It's 1/7, right? Same thing over here. 1/7. So in this case, why would I do that? Because the rules of exponents tell me that you multiply these now when you have a power to a power. And 7 times 1/7 is 1. And so now I've got b isolated. And now all I need is a calculator to do this side here. You're not going to be able to do all those by hand usually. So real quick, I'll just punch in that. If you guys want to try it too for the sake of practicing with the calculators, just know that when you do this, the 1/7, it has to be in parentheses on your calculator. Okay? If you don't do that, it'll do 10 to the first power, which is 10, and then it'll divide 10 by 7. That's wrong. If you do 10 parentheses 1/7, then it raises 10 to the 1/7 power. You should be getting 1.389. I'm going to round to the thousandths place. And so we have our b value. Now we're not quite done yet, right? We haven't found a. So what do we do? Well, same thing we do when we always do systems of equations. After you get one, you just plug that one back into one of the original equations and solve for the last one. So I'm going to go with the one that had the smaller numbers. 100 times a times b to the 7th. And we just found out that b now is 1.389. Okay. Once again, a lot of times you'll need to do this on your calculator, but in this case, I already know the answer. It's going to be 10. Divide both sides by 10. Oop, wrong one. And you get a equals 10. So now we have our answer. We found out that a is 10. We found out that b is 1.389 to the x power. And so what we did there was we took two data points from a word problem that we knew was supposed to be exponential. We took the exponential model and we did a system of equations to find a and b so we could find an equation that represents that data. So now that I have that, I could ask you a new question that's not in the word problem. I could say something like, how many flies were there on the 3rd day? You know, so what would this point be like back here? You just plug in 3 for x and you can calculate what that would be, right? So that's the benefit of getting an equation. All right, so there it is. A lot of steps there. Let's see how you guys can do one of these. Okay, go ahead. Okay, so they tell us that x represents, t instead of x. I guess that's fine. T represents days and the number of people is y. So on the 3rd day there's 54 and on the 6th day there's 1458. All right, so Edwards, Let's plug them in. Give me my first equation, what that should look like. Cool, thank you. And then, Amanda, would you give me my second equation? Cool. And then Eric, what do we do at this point? Good. And so that gives me 27, right? And we also divide this side. What's going to be over here? B to the third, right? So the A's cancel, and then 6 minus 3 is 3. All right. So, Tavier, what do I do now?
Parentheses. And then for the exponent, it would be 1/3.
Cool. That's right. 27 to the 1/3 should be 3. And so we have B. And Cleopatra, what do I do now? Plug it into one of the originals. I like the smaller ones. Okay, so I chose this one here. So that's going to give me 54 is equal to 3 to the third power is 27. And then we have the A. Dividing both sides, we get 2. And so, Connor, what is our final answer then?
But you want me to just say that y equals 2 to x.
Cool. I'm going to say T because that's what the word problem said. I wouldn't take points off for that myself. All right. So that's solving a system of equations, exponential function style. So there's that. Any questions about it? All right. Let's review how to find a linear equation. Okay. So it's a little bit more work, but it's not as complicated work. You got to find your slope. You got to find your b, and then you write your equation. Right? So this has been a while since we did this, unless you got to this on the worksheet on Friday, so it should be fresh in your mind if you did. To find your slope, you do y2 minus y1 over x2 minus x1, right? So we'll call these x1, y1, x2, y2, and we'll just plug stuff in. So it's going to be negative 3 minus 4.2 over 2 minus 5. All right. If I'm not mistaken, the top's just going to be negative 7.2. The bottom's going to be negative 3. And we can just change that into a decimal since it's already kind of an ugly number. 7.2 divided by 3. It's going to be 2.4. So that's my slope, 2.4. Okay. Then we got to find our b value. The way that you find your b value is you just plug stuff in, right? I want to figure out what this is, so I need to plug in everything else. So I need a y value, an m, and an x. So I'll go with the one that doesn't have as many decimals in it. I'll plug in negative 3 for my y. I'll plug in my slope, which was 2.4 that I just found in my last step. And then my x value is 2. So if I solve this, I get negative 3 is equal to 4.8. That's what 2 times that would be. And then we subtract both sides. And we end up with negative 7.8 is my b value. And therefore my equation would be y is equal to my slope. It's not negative though, was it? Plus my y-intercept. It's just a review. how to do that. So on the next slide, the reason we did that is because I'm going to give you a story problem, a word problem, and you're going to find two different models that fit the data. You're going to do an exponential and you're going to do a linear, and then you're going to decide which one actually fits the data best. Okay? All right. And that's, no, you can't see the answers. I need to erase all those answers. So give me a minute and I'll bring it back up. And you guys already have it on your thing. It doesn't have the answers on it, though. Done. All right, so this is what I'm going to let you guys work on for the rest of the block. We have a function, y of x, the population of a country. These numbers are in millions. All right. So go ahead and work through that. I'm going to give you guys, you know, as long as you need, and then we'll kind of discuss it and that'll close out our day. So go ahead and take a moment and check out your work, compare it, and if you have a question about one, I can talk to you about it.